So my name is Dan Shugar. The title that I've got on the screen here is a little bit different from what was on the flyer. I took an old Sherlock Holmes book and renamed it Inspector Kaskawulsh and the Case of the Disappearing River for reasons that you'll see in a minute. The real title of my talk is River Piracy and Drainage Basin Reorganization, the rerouting of meltwater from a particular glacier from one river to another, and actually went from the Bering Sea to the Gulf of Alaska. So here's the slide that you don't need to read. Basically, I'm a geomorphologist, which means I study landforms and landscape evolution. I use a variety of tools to do that, including things like lasers and drones and fancy autonomous vehicles and that kind of thing, as you'll see. Pew, pew, pew. So river piracy is what I'm talking about. River piracy is not this kind of river pirate, but rather when one river captures the flow from another one, essentially making a dry riverbed or one that's nearly so. I'm working on the Kaskawulsh Glacier, which is up in the St. Elias Mountains of southwest Yukon here. And the river normally flows north out the Yukon River to the Bering Sea, but now is actually flowing south down the Kaskawulsh River and the Alsek to the Gulf of Alaska. About 5,000 years ago, the same thing happened. The river actually flowed south down the drainage here to the south of Alaska. 300 years or so ago, this gray blob here, which is the Kaskawulsh Glacier, advanced and cut off the drainage, meaning that the lake here in blue filled up and cut a new drainage out the north going to the Bering Sea. So this is the present day conditions, or at least present as of a year ago or so. That figure came from this paper from 2006 by Clegg and others. The last sentence said, continued retreat of Kaskawulsh Glacier may result in piracy of the Slims River meltwater by Kaskawulsh River due to the much steeper gradient of the latter. That was the very last sentence in the paper. This is a photograph from the air of the Slims River Delta at Kluane Lake from, I think, 2015. And you can see the delta is full of water. This is the same, almost the same vantage point from this past summer. These photographs are from that delta, or at least the left one and the upper one there. The lower one here are these dust storms that were generated because there's no water in the river and all the dust was being picked up. The dry riverbed was also a nice spot for bears to walk down. So we flew up to the glacier terminus. Should I just wait until it advances? I don't know. I don't want extra time. And so some of you may commute by bike or by walking or by driving. I tend to commute by helicopter whenever I can. So we're flying here into the terminus of the glacier to do a variety of things. So we collect topographic data with a drone. We produce very high-resolution topographic models. We do high-accuracy GPS surveying. We dig around in the dirt. We do river surveying, as well as collect a lot of, or use a lot of data collected by satellites thousands of kilometers up into space to look at large-scale changes of the landscape. And so I'll show you some of the data and imagery from these various tools. So this is a Landsat image from 1972 showing the Kaskawulsh Glacier terminus here, and you can see a couple of lakes here. Most of the flow is heading north. This is 2015, and you can see this lake here has grown substantially, and the glacier's retreated. The yellow line is the 2015 terminus. In 2016, this is just a few, 2 months ago, you can actually see the terminus the lake here is actually disconnected from the Slims River, and all of the water is going out the Kaskawulsh River via a canyon cut through the terminus here. Upper left photo is a photograph from a helicopter showing that terminus and that new channel that's being cut. The image on the right is a drone-generated model of about 10-centimeter resolution from more or less the same perspective. This photograph is a little bit downstream. Flow here, this is the Slims River, or what's left of it. Flow should be going from right to left, but you can see now, I mean, you could walk across this really without getting your feet wet. So this once mighty river flows no longer. These data are water level in Kluane Lake downstream from the whole record. This middle panel is just the last few years, goes up and down, up and down. This last bit is just last year. The black bold line is this year, when the colored lines are essentially the long-term averages, min, max, etc. This middle figure is the same thing, but of the Kaskawulsh River, so where all of the water is going now, and you can see that the Kaskawulsh River is substantially more in flood than it normally is. This is the Slims River. We only have a couple of years of data on this gauge. It's brand new, but you can see unprecedentedly low levels in the Slims River. It's Kluane Lake, the upper data, the lake has never been so low in historic times. Mention that gradient. These two topographic profiles here are essentially the steepness, the profile of those two rivers. The bold is the profile of the river that all of the water is going down now. The issue here is that not only is it steeper, so you're going to have more erosion, but it's also at lower elevation. This has been normalized to be at the same elevation, but it's at lower elevation, and so that river is going to erode backwards over the next hundreds of years, 1,000 years perhaps, and capture Kluane Lake itself. And so it's likely that over potentially the next few hundred years, this entire system will be rerouted from the Bering Sea to the Gulf of Alaska. So that's what I did on my summer vacation.